Welcome. So now we're going to be looking at a limit of a difference quotient. So quotient means we're going to have a fraction, right? We're dividing. In difference, we're taking the difference of a function evaluated at two different quantities. Two different quantities that are very, very close together. This is called a limit of a difference quotient. Right? So we have the function f of x equals x squared minus 1. We want to find the limit of f of 3 plus h minus f of 3 as h approaches 0. Right? So now we need to replace the f in this one with the function f of x, and this is a composite function. So that means everywhere we see an x, we're going to be plugging in whatever's in the parentheses there, 3 plus h or an 8, excuse me, a 3 plus h or a 3. Right, so we have the limit. I'll just keep writing and it'll eventually catch up to me as h approaches 0. Right, so we have, so f of 3 plus h means we have 3 plus h squared, right, because we're replacing the x with the 3 plus h. And then minus 1 because that's the rest of the function. And then minus, I'm going to use parentheses so that I remember to subtract everything. We're going to plug in 3 now where we see an x. So that'll be 3 squared minus 1. Right, so the first part of that equation is f of 3 plus h, and the second part is f of 3, and then we're dividing by h. Let's simplify this. So we have the limit as h approaches 0. So 3 plus h squared, we do need to square that out. And just to show you, we would definitely need to do something. What happens if we plug in a 0? Well, you can see right away that the denominator, of course, would go to 0 if you plug in 0 for h. How about the numerator? Right, so I'd have, if I plug in 0 for the numerator, I'd have 3 plus 0 squared, so that's going to be 9, minus 1, and then I'll be subtracting a 9 minus 1. Right, well, now I'm just going to have 9 minus 1 minus 9 plus 1, and of course that's just 0. So you see we can't substitute in because we would have an indeterminate limit. So we're going to need to simplify. Right, so we're going to do expand. So squaring, that's pretty easy. If we were cubing or raising to another power, right, we could use Pascal's triangle or the binomial theorem to get that. Or we'd have to just multiply it out. But you'll at least be able to use Pascal's triangle. But here, this one's kind of easy, right? So this is just 3 plus h times 3 plus h. Right? And so if I have, I'm just going to put it right over here. Right? So if I multiply the first terms, that's just going to be 9. If I multiply the outside terms, it's going to be a 3h. If I multiply the inside terms, that's going to be a 3h. And then the outside, the last two terms, that would be an h squared. Or I could just remember a little property for squaring. So you can remember that. Right? And so if I'm squaring, and I'll just put that over here, a little property for squaring. Right? It's going to be the property for squaring. Right? So it's going to be the first one squared. And so let's just call this a and b. Right? So it's going to be a squared. And then it's going to be 2 times a times b. Right? So you're going to be multiplying them together, and you're going to be doing it twice. And then it's going to be the b squared. All right? So you can use that little property to help you remember, or you could just write it down and then FOIL. All right? So I'll just use the little property. So I'm going to have a is going to be squared, so that's going to be 9. And then 2 times a times b, so that would be 2 times 3 times h, so that would be 6h, and then it would be h squared. And if you remember what I had up here before I erased, I had 9 plus 3h plus 3h plus h squared. So you can see that, yep, that's right. All right, so now we're going to distribute that. Oh, don't forget the negative 1 there. And then we'll distribute the negative sign. So we're going to have and we may as well just simplify that, right? All right, so that's going to be 9 minus 1. All right, so that's 8. So we're going to have minus 8. All over h. Let's combine our like terms. Limit as h approaches 0. So I've got 9 minus 1 minus 8. That's going to be 0. So I'm left with 6h plus h squared over h. And notice if I were to plug in 0, I would still have the numerator going to 0 and the denominator going to 0. We're going to have to reduce first. So let's factor out an h. So its limit as h goes to 0. And we're going to just factor out the h. And we'll have 6 plus h in the numerator and h in the denominator. That would cancel. So now I have the limit as, oops, not x, h. H approaches 0 of 6 plus h. So that's just going to be 6 plus 0, or just 6. Right? And so now we have found the limit of this difference quotient. So that means that as we get closer and closer, as h here gets closer and closer to 0, the value of our function is getting closer and closer to 6. Does it mean the value of the function is going to equal 6 at some time? No, it doesn't. It just means that we're going to get closer and closer to 6. Let's look at one more. I only have two examples on this podcast. So sometimes you have to plug it in, and other times it's already written in for you, right? So this technically, if they had said, our function would have been, by the way, f of x equals x cubed, and then it would have been x plus h minus x, right? But this was already written in for us, so we didn't have to plug it into the function. It's already plugged in for us. So we're going to cube. Now I could write x plus h times x plus h times x plus h, and we'd multiply these two, and then we'd distribute that one to whatever was left, or whatever equation we had after multiplying x plus h times x plus h. But let's use a little bit easier way, and you'll be able to remember this, all right? So the limit as h approaches 0. I already had the problem written, so let's just start cubing. All right, so a little property. For cubing, or cubes, all right? So let's call this one A, and let's call this one B, all right? So we're going to have, and this would also work, by the way, if there was a coefficient. So if this was 2x instead of x, you would just treat 2x as a. So we're going to have a cubed and b to the 0 power plus a squared and b to the first power. And by the way, it's a plus because there's a plus right there. And then plus a to the first, b squared, and then a to the 0, b cubed. So look what's happening, right? One's going down in the exponent while the other one goes up. So we can use that handy dandy little property. I recommend you write both those handy dandy little properties down if you don't know the property for the squares, and if you don't know the property for the cube. So you have that handy next time you have to cube something. All right, so this is going to give us, so I'm going to have x cubed. Now if it's h to the 0, anything to the 0 power is 1, right? So there's really no point in me writing 1 down. Plus, now I'm writing an a, sorry. Plus, I'm looking at the a and I'm writing an a. X squared, and now we have h to the first. And then we have x and h squared. And now we would have x to the 0, right, because going down, and h cubed. But really, is there any point in writing x to the 0? That's just 1. 1 times h cubed is still h cubed. Oh, and then don't forget, can't stop, minus x cubed all over h. Let's combine our like terms. I hope you see right off the bat you have an x cubed and a minus x cubed. So now we have the limit as h approaches 0 of x squared h plus xh squared plus h cubed, all divided by h. And we can see right away, if we were to plug in 0, right, the numerator and the denominator would go to 0. Every one of those terms has an h in it. So we're going to have to factor. This is an indeterminate limit. Right? And so we're looking at what happens when we take the difference of 2 points, and those 2 points are getting closer and closer to one another. Right? This is actually going to be an important concept later on. So we have the limit as h approaches 0, and I'm going to factor out the h. So I have an x squared plus x times h plus h squared, all divided by h. The h's will cancel. So we have the limit as h approaches 0 of x squared plus x times h plus h squared, and now we're going to plug in the 0 for the h. So that's going to give us an x squared plus x times 0 plus 0 squared. Right? So the only thing that's going to be left is the x squared. Hey, we didn't get a number, we got a function. And in this case, it will be a function. What does this mean? You're going to have to wait, stay tuned for a later lesson, and then you'll find out. Right? But this is how you take the limit of a difference quotient. I'll be posting the whiteboard practice. I don't know if it's the next slide. Let's just take a look. It is. So here are 2 problems, kind of like the ones I just did. Right? And you'll solve these. Thanks for watching the podcast. Bye for now.